Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. Up to now in calculus, we've spent a lot of time computing limits and checking continuity. But today's idea is different. Sometimes in math, we don't actually need to find a solution. We just want to know that a solution must exist. That's exactly what the Intermediate Value Theorem gives us. It's a powerful guarantee that an equation has a solution, even when we can't solve it algebraically. Now, before we get started, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. So the Intermediate Value Theorem states, suppose that f is continuous on the closed interval AB, and let n be any number between f of a and f of b, where f of a does not equal to f of b. Then we can state that there exists a number c that's in the open interval AB, such that f of c is equal to n. So let's unpack that. And we're going to do that by drawing a diagram. So suppose that we have some continuous function, f, on the closed interval a, b. So that's going to be my a and that's going to be my b. So let's say my function f looks something like this. Now this over here, that is going to be my f of a. And then right over here, this is going to be my f of b. So here, this is my function f. Now n can be any number that is in between f of a and f of b. So meaning we can pick n to be any number in between here. So let's say we pick n to be right over here. Then what the Intermediate Value Theorem says is that there has to exist a number c in between a and b, so meaning c is going to be in the open interval a to b, such that f of c is equal to n. So in this particular case, we can see that c is going to be right over here. So this is going to be our c, because n in that case is going to be f of c. So as you can see, we could have picked our n to be here, or here, or here. As long as it's in between f of a and f of b, we will always be able to find a c such that f of c is equal to n. And this is on the condition that our function f must be continuous. And also that our n to be between the values f of a and f of b. And lastly, notice that this theorem only guarantees existence and does not actually help us find the exact value. So not the value. So now let's take a look at how to use that through an example. So here we want to show that x cubed plus x minus 1 equal to 0 has a solution in the interval 0 to 1. Now note that while we have ways of solving quadratic equations, we have no simple way of solving cubic equations. So meaning it's impossible to solve most cubic equations algebraically. But notice how for this question, we're not asked to find what the solution is. We're just asked to show that there is a solution in the interval 0 to 1. So this is where the Intermediate Value Theorem comes in handy. But before we can use it, we need to make sure that the conditions are met. So firstly, our function f here is going to be the cubic function. So that is x cubed plus x minus 1. And since this is a polynomial, we know that it is continuous everywhere. So of course, because it's continuous everywhere, it is continuous on the interval that we're interested in, which is 0 to 1. So now notice 0 is going to be our a value and 1 is going to be our b value. Next, we need to find what f of a and f of b are, and they have to be different. So f of a is going to be f of 0, so that is going to be negative 1. And then f of b is going to be f of 1, which is going to be equal to 1. So therefore, now we can use our Intermediate Value Theorem, and we can say that by the Intermediate Value Theorem, there exists a c that is in our open interval 0 to 1, such that f of c is equal to 0. And we can do that because 0 is in between -1 and 1, which are the values for our f of a and f of b. So again, notice that we didn't actually find the exact solution for x. All we did is use the intermediate value theorem to say that there exists a solution in the open interval 0 to 1 such that our function is going to be equal to 0. And now let's take a look at another example. So this one is stated a little differently. We want to show that the equation e to the power of x is equal to 3x has at least one solution. So first of all, at first glance, it looks like we have two different functions. We have e to the x and we have 3x. And secondly, we're not given a particular interval to look at. So the first thing we're going to do is we're going to move all the terms over to one side. So which means we're going to let our function f of x be equal to e to the x minus 3x. Because saying that the equation e to the x is equal to 3x has at least one solution is the same as saying e to the x minus 3x is equal to 0 has at least one solution. So now we know that we want to show there is at least one value of x that is going to make e to the x minus 3x equal to 0. And again, we don't need to find what the exact value of x is. We just need to show that it exists. So following what we did in the last example, to show that there is a solution, we need to find one x value that is going to make our function positive and another x value that is going to make our function negative. So even though we're not given the interval this time, we can do a little bit of guess and checking to find one positive value and one negative value. So let's start by checking a is equal to 0. Now when a is equal to 0, f of a is going to be equal to e to the 0, which is 1, minus 0. Okay, so now we have our positive number. Next, we're going to find a value b so that f of b is going to be a negative number. So let's try b is equal to 1. So now f of b is going to be e to the power of 1 minus 3. So now e is 2 point something. So 2 point something minus 3 is going to give us a negative number. So therefore, we have f of b is less than 0, and then we have f of a is greater than 0. And of course, the most important thing is that our function f of x is continuous. And this is because we know that e to the x is continuous and 3x is continuous. So therefore, the arithmetic combination of those two continuous functions is continuous. And now we can say that by the intermediate value theorem, there exists, so this little backwards e here means there exists, a value c that is in the interval 0 to 1, such that f of c is equal to 0, which is in between f of a, or f of 0, and f of 1. And thus, by using the intermediate value theorem, we have proved that the equation e to the x is equal to 3x has at least one solution. And we've shown that it's going to be in between 0 and 1, even though we don't know what the exact value is. So now let's do a recap of what we covered in this video. We learned that the intermediate value theorem guarantees existence of solutions, but it doesn't help us find the exact values. And in order to use it, continuity on a closed interval is essential. And we used it to show the existence of solutions for certain functions equaling to 0. And the reason is because if a continuous function changes sign, then it must cross 0. So the intermediate value theorem is especially useful when equations can't be solved algebraically. And now it is your turn to give this a try. Can you show that this equation on the screen here has at least one solution? Make sure to leave your answer in the comments below, and let us know what other calculus topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.